Hello everybody and welcome back to B.PharmaWise. In today's video, we are going to discuss assay of ammonium chloride by direct method using aqueous acid-base neutralization titration. So we'll try to cover everything. We'll look at principle, reaction, the procedure, important points and calculations also. So let's start. See, ammonium chloride is a salt. It's not an acid, it's not a base. So how we are going to do the assay for ammonium chloride? So first let's discuss the reaction, what is going to happen. This ammonium chloride will be adding water to it. During assay, first we will dissolve it in water. Once you dissolve it in water, it will give ions and it will convert to something like this: ammonium hydroxide and HCl. Now as you can see, 1 mole of ammonium chloride means 1 mole of salt upon dissolution in water is getting converted to 1 mole of ammonium hydroxide and 1 mole of HCl. Now if you look at it, 1 mole of ammonium chloride is liberating 1 mole of HCl. So I can quantitatively titrate that HCl with sodium hydroxide solution. So it is going to be a strong acid, strong base titration, resulting in formation of salt and water. Now it looks good, but see that ammonium hydroxide or ammonia in that case is a weak base, and that base is going to interfere, right? Because you cannot just titrate HCl, there is ammonium hydroxide in the solution and we have to think about it. So what we can do is we can convert that ammonium hydroxide to something that will not actually interfere in this reaction. So to do that, what we do is this ammonium hydroxide is actually reacted with something called formaldehyde. Now when you treat it with formaldehyde, it forms a soluble complex called as hexamethylene tetramine, and some water molecules are formed. So as you can see, the problematic part of the reaction is being taken care of by the formaldehyde solution, because it is then converted to urotropin or hexamethylene tetramine, which is a soluble complex. Now it will not come and interfere with the reaction of liberated HCl with NaOH. So what is going to be the assay of ammonium chloride? Just imagine, in the conical flask you are going to take your ammonium chloride, say 0.1 gram, and dissolve it in water. Once you dissolve it in water, you are going to have ammonium hydroxide and HCl. Now to take care of this ammonium hydroxide, you will be adding formaldehyde, which then will convert to hexamethylene tetramine. So it is now in soluble complex form and HCl is remaining in the conical flask, and then in the burette we will take sodium hydroxide, and this HCl and sodium hydroxide can then be quantitatively titrated with each other, right? Now here the analyte is ammonium chloride and the titrant is NaOH. Now when we are using NaOH as a titrant, it has to be a standard solution, and NaOH is a secondary standard substance. So first we have to standardize the NaOH solution. So either you do it with potassium hydrogen phthalate or you do it with oxalic acid. Whatever way, you first standardize the NaOH solution, and then after knowing its actual concentration, you use it for the assay. Now one thing I want to add here, in the process we are adding formaldehyde. So whenever you are adding formaldehyde, you have to do one procedure before adding formaldehyde in the solution. Why? See, formaldehyde contains acidic impurities, one thing, and if you have stored it for a longer period of time, this formaldehyde might have undergone oxidation and it might be converted to formic acid. Now in either cases, either it is oxidized to give formic acid or it contains some acidic impurities, that acid content in formaldehyde can interfere with your titration, right? Because if it adds its own acidity to the solution, then we'll need more NaOH than required and it will give us falsely elevated reading. So our titration error can worsen. So to avoid it, we have to first neutralize the formaldehyde. So how we will do it? We will just neutralize it using phenolphthalein indicator till it becomes just faintly pink, right? So once you neutralize it to phenolphthalein and it is now just faintly pink, it means the acidity has been neutralized. Now you can add that formaldehyde to your assay. So this is how we are going to actually perform the assay. This is the reaction. Now for calculations, you can go with factor method or you can go with Mili equivalence method. So I'll show you the Mili equivalence method. So what we generally do in Mili equivalence method is we say Mili equivalence of analyte is equal to Mili equivalence of titrant. Now as you know, ammonium chloride is my analyte and sodium hydroxide is my titrant. Now in the procedure you have weighed the quantity of ammonium chloride and dissolved it in water. So it is your solid component, right? So how we are calculating number of equivalents? Generally weight of substance upon its equivalent weight. This is how we calculate equivalents, but here we are taking milli equivalents. So I'll take weight in milligram upon equivalent weight is equal to. Now NaOH is filled in burette, it is prepared as a solution and it is my liquid component. So instead of writing equivalent of NaOH, I have to mention the volume and concentration. We do the same thing for the factor also. For 1 mole of NaOH, in factor calculations what I write? I write 1000 ml of 1 molar NaOH. So volume and concentration has to be given. So here also in normality we are taking the concentration. See, whenever you are taking molarity concentrations, you can go with factor calculations, but whenever you are taking the concentrations in normality, you can easily use this equation. So how we will do? NTVT, normality of titrant and volume of titrant. I'll tell you. Now I have to calculate the weight in milligram. So for that I should know the equivalent weight. So ammonium chloride is a salt. And how we calculate the equivalent weight for a salt? So it is calculated equivalent weight for a salt by taking its molecular weight and dividing it with number of H plus ions replaced from its parent acid or from its conjugate acid. So ammonium chloride is my salt and the parent acid is HCl. So as you can see, one H plus ion is replaced by ammonium ion for formation of this salt. So obviously the equivalent weight will be molecular weight upon 1. The molecular weight is 53.5 by 1. So my equivalent weight is also 53.5. Now NT means normality of titrant, which should be exactly known, and for that only I have done the standardization of NaOH. At the end of standardization I have come to know what is the actual normality of NaOH. That value I'll put here. Okay, for the sake of calculation I'll say 0.1 normal is my actual normality. And what is the volume of titrant? It is the burette reading, mean burette reading for the assay of ammonium chloride, right? So whatever it is, XML, YML, I'll take 20 ml for example. So now I will calculate weight in mg is equal to 0.1 into 20 and this will go for multiplication 53.5. So answer will come in milligram. Then but I have weighed ammonium chloride in grams. So I'll convert it back to grams. So weight in grams is equal to these many grams. So just shift 3 decimal points to the left or divide by 1000 and you'll get weight in grams. So what you have done? You have actually measured the amount of ammonium chloride in grams, say 0.1 gram. And then from the calculation you are theoretically calculating how much amount of ammonium chloride is found in the conical flask at the end of titration. So this is like I have written 100 marks paper and I have got 70 marks. So what is my percentage? 70 upon 100 into 100. This is what we do, right? So similarly for percent purity calculations we will do percent purity is equal to weight found upon weight taken into 100. So I have suppose taken 0.1 gram of ammonium chloride by weighing it accurately, but at the end of titration theoretically I have got say 0.099 grams of ammonium chloride, then into 100, so it is going to be 99%. So the percent purity will be 99%. This is how we are going to calculate the percent purity. Assay means you are actually calculating the percent purity of the analyte. So here by this method also we can calculate percent purity. This method or this calculation technique is particularly useful if you are dealing with normality concentrations. For molarity you can easily use factor calculations. So I hope you understood the assay of ammonium chloride. If yes, don't forget to like the video, share it with your friends, subscribe to the channel, like the video and keep watching B.Pharm. Let's meet in the next one. Till then, take care. Bye bye.